Fair warning, this example is going to take a little bit to solve out. This entire video is just going to be how to solve out this single example. The difference between this example and our earlier video on solving radical equations is that the first video was talking about how to solve equations when there is just one radical, which makes our process a bit easier. All we got to do is just isolate the radical, find whatever power we need to cancel it out, and move on. Here, as you can see, we have two radicals. So what we're going to want to do is we want to isolate the two radicals from each other, meaning we want to put one on either side of the equation. So, for example, I could do that by adding the square root of 3x to the other side. So then, we'd have the square root of x plus 4 is equal to negative 2 plus the square root of 3x. Once we've done that, once we've split the two radicals up from each other, we're going to go ahead and take it to whatever power we need to cancel out that radical. Well, the opposite of square rooting is squaring. So, we're going to square both sides of the equation. Now the problem with that, or I shouldn't say problem, what's going to make that difficult is that on the right side, we have an expression that we are squaring. The left side is very straightforward. The square root and the square cancel out, and we just end up with x plus 4. But on the right side, you're taking a quantity squared, which means we have to take negative 2 plus the square root of 3x times itself. Another negative 2 plus the square root of 3x. In other words, we have to FOIL out. So if we do that, we would take negative 2 times 2, or times negative 2, which would give us positive 4. Negative 2 times the square root of 3x would be a negative 2 square root of 3x. The square root of 3x times negative 2 would also be negative 2 square root of 3x. And then finally, we need to take the square root of 3x times the square root of 3x. Since they're both underneath a radical, the same radical, they're both underneath a square root, we really can multiply those together. So underneath a single square root, we are taking 3x times 3x. Or in other words, we're taking 3x squared. Which means the square root of the quantity of 3x squared would just cancel out to simply 3x. Meaning what we're really looking at here is x plus 4 on the left side equals 4 minus a 4 square root of 3x, because recognize from our rules for adding and subtracting radicals in our previous lesson, since they're both a square root and both a square root of 3x, we can add them together, and so negative 2 minus 2 would give us negative 4 square root of 3x. And then we just have 3x. Because again, we could rewrite this square root as the quantity of 3x squared, and the square root and the square would cancel out. Well, what you may notice here is that we have an issue. We still have a radical, this square root of 3x, which means we're not ready to just get x by itself and solve out. The part that makes this problem so long is it's almost kind of like we hit a reset button. Now we have to go all the way around the world again, and we have to isolate the radical, cancel out the radical with squaring, see what we have, then we can try and actually solve this out. So, I'm going to subtract 4 over, which would just cancel out, and then I'm going to subtract 3x over, which would give me negative 2x is equal to negative 4 square root of 3x. And now, again, deja vu, we need to square both sides. Well, negative 2x squared would give me a positive 4x squared. Alright, negative 2 squared is positive 4, and x squared is x squared. Negative 4 squared would give me 16, and the square root of 3x squared would give me 3x. Then we'll take 16 times 3x, and looks like we are looking at 4x squared equals 48x. So we have successfully got rid of the radicals. That was a lot of work, but we did successfully get rid of them. Now we have to figure out how to solve this equation. Well, I have both an x squared and an x. I have two instances of x, which means I cannot simply just get all the x's, or get x on one side and then just divide over. I can't solve out normally. What we're going to have to do is solve out the way we would for a quadratic, which means I want to get everything on one side to get equal to 0, and then you can choose whether you would like to factor or quadratic formula. Or you could complete the square, I guess, as well. In any case, I'm going to subtract 48x to the other side of the equation, so that we've got 4x squared minus 48x equals 0. Well, if I want to factor this, I notice that there is a GCF of 4x that I could pull out, which would leave me with x minus 12. Now that we've factored, we can set each piece equal to 0 separately and solve out. So 0 divided by 4 would give me x equals 0, and adding 12 over 0 plus 12 would give me x equals 12. So we finally got some possible answers here. But remember, we're not done yet, because we've discussed already that you need to plug in your answers and check them to make sure they really work. So we need to go all the way back up to the original problem and plug in 0 and 12 to see what works. So if we plug in 0, we'd have the square root of 0 plus 4 minus the square root of 3 times 0 is supposed to equal negative 2. Well, 0 plus 4 would give me 4, and 3 times 0 would give me 0. The square root of 4 is 2, and the square root of 0 is 0. I do not believe that 2 minus 0 gives me negative 2. It gives me positive 2, and that is not true. So 0 is actually not one of our answers. So we go back down here, we're scratching that off. Hopefully 12 ends up working, or else we just did a lot of work for a no solution. But let's find out. If we plug in 12, we've got the square root of 12 plus 4 minus the square root of 3 times 12 equals negative 2. 12 plus 4 is 16. 3 times 12 is 36. The square root of 16 is 4, and the square root of 36 is 6. I do believe that 4 minus 6 really does give us negative 2, which means this one checks out. So our final answer would simply be 12. This is a long process, and I don't want to act like it isn't. Remember, or to recap what we did, we started off by taking the two radicals and splitting them up. We moved each of them to one side of the equation. When we squared, that forced us to have to FOIL because there was a constant there. If there wasn't a constant, this would have been much, much easier, but there was. We were forced to FOIL, and when we did that, we ended up with a radical still left over, this negative 4 square root of 3x. After we got done foiling, that is success, right? We did get from 2 radicals down to 1, so that is progress. Then we isolated the new single radical that we had accidentally created, and we canceled out that radical again. Throughout that process, and you should expect throughout all that process, we ended up making an x squared. So then we had to solve somehow by a strategy used for quadratics. That can be factoring. That could be the quadratic formula. That could be completing the square. It's up to you. But after we solved out the quadratic, we then double-checked by plugging our 2 answers in. This time only one of them worked. Recognize that's not a guarantee, that's just how it happened to be this time. Could be both of them works, could be none of them works, just depends. But take your time through these and I think you'll be able to get them.